Video 7. Engines are truly the heart of every airplane, and without them, flight as we know it would be impossible. But how exactly do these powerful machines, both propellers and jet engines, create the force needed to push an aircraft forward and lift it into the sky? Today, we're going to break down the science behind airplane engines in simple and fascinating detail. Let's start with propeller engines, also known as piston engines or turboprops. These engines work by spinning large blades at incredibly high speeds. The propeller blades cut through the air, pushing it backward. According to Newton's third, every action has an equal and opposite reaction. Pushing air backward creates a forward motion called thrust. This thrust moves the aircraft ahead. Propeller engines are considered ideal for smaller planes because they operate efficiently at lower speeds and lower altitudes. Aircraft like the Cessna 172, Beechcraft King Air, and many regional commuter planes use propeller engines for short to medium distance flights. These engines are reliable, fuel efficient, and great for training, cargo, agricultural work, and regional travel. Now, let's move to something far more powerful: jet engines. Jet engines operate on a completely different principle, using a process called suck, squeeze, burn, and blow. First, air is sucked into the front of the engine by a large spinning fan. Then, the air enters the compressor section, where multiple rotating blades squeeze it into a smaller space, dramatically increasing its pressure. Next, fuel is injected and ignited in the combustion chamber, causing an explosive expansion. Finally, the hot gases rush out of the back of the engine at tremendous speed. This rapid expulsion of gas pushes the aircraft forward with enormous thrust. That's the basic idea, but modern jet engines are far more advanced. Most commercial aeroplanes today use turbofan engines, a type of jet engine that is optimized for both power and fuel efficiency. In a turbofan engine, the large fan at the front pushes a huge quantity of air around the engine core, not into it. This bypass air provides most of the thrust, making the engine quieter, more efficient, and more powerful. Turbofans power practically every major airliner, including the Boeing 737, Airbus A320, Boeing 777, and Airbus A350. They are engineering masterpieces capable of producing tens of thousands of pounds of thrust. For example, a single GE90 engine on a Boeing 777 can generate over 100,000 pounds of thrust, enough to power a small town's electricity needs. Different jets use different types of engines. Turbojet engines were the earliest form of jet propulsion, used in older fighter jets and early airliners like the Comet. They produce extremely high speeds but consume a lot of fuel. Turboshaft engines, on the other hand, direct their power to drive a shaft instead of creating thrust, making them ideal for helicopters. Turboprop engines are hybrids that use turbines to spin propellers, providing excellent short runway performance. Each design serves a specific purpose. Jet engines dominate modern aviation because they allow aircraft to fly faster, higher, and farther than propeller-driven planes. Commercial jets cruise at around 35,000 feet and speeds of 800 to 900 kilometers per hour, making long-distance travel possible. Military jets use afterburners Sextra fuel injected into the exhaust to create massive thrust, enabling supersonic speeds over Mach 2. Understanding how engines function helps us appreciate the force required to overcome gravity, drag, and the enormous weight of an airplane. A fully loaded Boeing 747 can weigh over 400 tons. Yet its engines generate enough thrust to lift it off the ground and carry it halfway around the world. In the next video, we'll step inside the cockpit and explore the flight instruments, controls, and systems pilots use to manage these incredibly powerful machines, from autopilot to navigation screens. The cockpit is the brain of the aeroplane, and you're about to see how it all works.